Welcome friends once again to the NPTEL MOOC module on handling healthcare data. We are on the 4th week and about to finish the 4th week, and this particular lecture is in addition to the lecture we have taken on the previous class, that is data browse and basic statistics. Okay, if you are thinking of two variables as a dependent variable and an independent variable, the dependent variable is usually listed first. So, it goes in the row. Okay. So, usually when we do some sort of cross tabulations or like deriving this kind of two-way table results, we should keep in our mind that which one is going to be a dependent variable and which one is going to be an independent variable, and so that you will have more meaningful interpretations. We need to add options. Options like I have already mentioned, we can give row options or column options and its results, how it appears, how it is useful, we have already explained. Okay. So, if we even NOF command, if you give it tab two variables, this is first variable, this is second variable. If you NOF and row, so it is only going to give you not the frequencies, it is going to give you the percentages. Okay. Similarly, NOF column, you can do it, you can add extra option that is going to give you column wise percentages. Most important, though less often used, but very rarely discussed, you can also take a note called cell percentage. Like we compare these out of these or these out of these out of these or these out of these, if it is column percentages, or if it is by row percentage, we compare with the row. But in this case, this is not going to be derived, this is going to be straightway derived from the 100 of this. Okay. So, out of total persons, both rural, urban, and in this case nature of treatment, in our discussion, how much percentage carry on one cell. Okay, this is one cell, this is second cell, this is third cell, fourth cell. So, in each cell what is the percentages. Okay. This is also another cell, this is another cell. So, out these would be your 100 instead of either row or in the column. Okay. So, no frequency command and its details we explained already through operation. Then second one is called no label. By default tab shows value labels for any variable that has already entered with them. If you need to see the actual values, add the no label option. If you write no label, then the actual code name will be displayed on the result. Like since we haven't labeled in our variable, so we are not going to run this command at this moment. You can label, I will discuss about labeling, then we can run it accordingly. Missing, to check the number of observations with missing values, missing command could also be added as an option. All right, that will be giving you missing values. In case of two-way tables, one of the convenient tool is tab 2 that produces all possible two-way tabulations of the variables specified in variable list with options. First only, that is displayed a cross tabulation of first variable with other variables row and column wise. So, tab 2 and variable list that you can do it, and all the operation you can do it. Okay, you can just operate on your own, and I am sure that is going to be helpful. Another interesting table for us to operate is called three-way table. Three-way table is often required for the researcher who wishes to derive results not just by by two variables, that might be third interaction, third common point through the third variable. So, like for example, we explained here sector and gender, the third variable could be by their education, how education is actually linked to other two variables. Okay. Or sector, how maybe your first variable and other two would be gender and education. Okay. So, you cannot give tab a list like tab and all those 3 variables to give you the result. Just tab and on all those list of 3 variables is going to throw you error. However, you can apply one command called by command, by sort command. By sort command is because it will sort the first variable. Okay, first variable, that is, suppose you have entered rural here first or sector, if it is sector, and this is your gender, and this is your education. Okay. So, sector, it will actually sort the variable and its entries, then it will compare the tabulation of these 2 other variables. You can add as many variables as you need through by part of the command. Okay. So, by part of the command we can actually add more variables as well. However, the amount of output you will get can become cumbersome quickly. Okay, if it is instead of 2 layers or 3 layers, if there are 4 layers of information and their intricacies explained, it is very difficult to read at a go. So, that is why the results are going to be very complicated. So, usually we operate through at maximum 3 okay, through this command, and we can also operate here by sort, then there will be command by sort command. We will be taking 3 variables here. Let be sector is your first variable, by sort sector, then colon, then our tab. Tab 2 variables, let it be first variable is our gender, okay. Then another categorical variable we can find out from the list of the sample data that is being shared to you. General education, yes. So, this is our command. All right. So, here you will get all sort of information by sort. Why by sort? First is your sector by sort, it has sorted out sector to with the first entry is 1, then the second result will be on 2, okay, 2 is your maybe urban area, first one is rural area, okay, gender and education. So, gender we have entered first, so it has taken on the row, and education on our second variable on the tab command, that is displayed on the column variable. So, like here in rural area, what is the interpretation in the rural area? How many are having how many males are having one level of education, or how many males are having 16th years of education, of general education. So, this is possible to find out the third information as well. So, on but in the two-way table we could not able to get the third information. Here it has given better idea for interpretation. Okay, so this is what we have already guided. Similarly, 3-way, 4-way, 5-way and more tables in state are possible. Instead of tab command, if you give simply table command. Table command is effective more when you have more than 2 3 variables. Table command, so what it takes, like your row variable, then column variable, then your super column variable, then you can actually sort it by your super row variable list. Okay. So, then you can add some content like frequencies, it will give you the result as frequency. The note here we have mentioned for you is that the third variable we use with table command is called super column variable. Basically after 2 variable there will be a third layer called that variable is called super column variable. The list of variables attached with by options are called super row variables. Okay. So, by option, once we have sorted out through the row, then we can find out these very clearly. Creation of new variables. how to have new variables we can create in Stata. The original data set variables may not necessarily be the variable we need for analysis. Instead, we often need variables that are transformations or combinations of other variables. The most important Stata commands for creating new variables are like generate, replace or record. These three we are going to explain you what are the differences in each case. They are often used together, okay, often together, but there are certain differences. Even those who are familiar with Stata, you might be confused with these three. Let us get understood very clearly. Stata variable naming rules, how we can name the Stata variables. Begin variable name with a character, okay, some character, then use only letters or numbers or the underscore, okay, then do not use, that is more important, do not use this letter, these special characters are not allowed. Special characters like these are not allowed while naming a variable in Stata. Variable names must be no longer than 32 characters. Okay. So, more than 32 characters Stata is not going to name it or consider as a name. So, okay. So, some suggestions we have mentioned here, like use as short a name as possible. 8 to 10 characters are usually considered to be ideal name. Choose a name that is as descriptive as possible. Avoid names that are the same as data names for commands for functions. Okay. Like function command and the variable command, if you just simply give the same, okay, it might be making you more confused. So, better to avoid all those things. This is quite important, those are very new and at the entry level. Okay. So, we have to clarify these two again, generate and replace. Then what do you mean by generate first? The primary commands for creating and changing variables are called generate. They are usually abbreviated with GN or G. And replace, like which like other command that can destroy information and has no abbreviation. So, replace word has to be carried as it is. The generate command creates a new variable use certain expression. So, you have to give, like if you are generating a variable, then you have to express it with certain expression. Expression might be with some arithmetic equations, so function or logical operators. Replace can be used to create variables that are formed by forming arithmetic or logical operations on existing variables. Some examples we have put it, you can experiment on your own because of time paucity for the class. I am not operating everything, but the same approach you can apply and find out. Like generate GN, you have to write it down. Then if you want two variables to be averaged, two numeric values, you want that this should be averaged, okay, or by 2, or if 3 variables are there by 3. Okay, then you have to divide it by 3. So, that will give you average value with this gen command. Then creating log of a variable, like log of a variable means here we are saying logarithmic transformation. Okay, so, here I mean logarithmic transformation. Okay, so here by default it consider natural log. Okay, so generate log variable, we have given this name as log underscore name of the variable, maybe expenditure. So, log expenditure, log underscore expenditure. Then ln within bracket the variable name, maybe initially it is expenditure. Okay. Then log underscore expenditure is equal to ln within bracket expenditure, variable name is expenditure. That will be generating a new variable called log variable. Okay. So, like here squaring a variable, another one, like we are generating a variable, we need to square it. Why squaring? Like some variables by default considered to be linear, okay, and the linearity of the variable is not going to give you much difference in the model. So, if you want that some sort of major jumps or some nonlinearity in the data is required for identifying the role of that particular variable, then you can take the square of that variable or even sometimes q of that variable. How we can do it? Like in your data, I am just going to show it. It is on the data, one age variable is with us. We usually do that. Okay, so let us see how age variable is whether we have squared it or not. We need to just check first. So we have taken age here, and we'll define a new variable called gene. Okay, then variable name is square age, sqr maybe square age underscore age. Okay, so is equal to age to the power 2. So power we will be using this and 2. Okay, so this will be converting the variable. Again there are some problem because of the data by default is in string. So we have to convert this to dstring first. We will make it to numeric value. Okay, dstring age, then we will go by the same command. Okay, so and replace. So it replace the original variable. Replace command, you can just take a note why we applied a replace because we have dstring changed the nature of the variable, and now if we do not replace, then there will be some mismatch. Okay. So now our variable is in numeric entry, numeric values. Now if you apply the command generate square underscore age, we have defined a new variable name, then equal to age to the power 2, then this is going to convert it. Okay. Now on the variable list, you can see a new variable has already been generated, that is with the name square underscore age. Now you can check whether it has been squared or not. BR of these two variables together, age and square age, BR age and square of age. So now you can just have a check. Now just have a comparison. Age 20, now it has been squared as 452, then its square is 2704 and etc. Okay, 6, 36 etc. all have been squared. Okay, so let us make a move to our next explanation. Replace we have already shown through the operation. The replace command modifies existing variables in exactly the same way as generate creates new variables. So generate if logarithm transformation you will do it. Okay, then you can also replace the variable when you know that there are some missing values. In the data in the data entry there are some missing values as dot. Okay, that you can replace to 1 log 1. Okay. So replace you have mentioned the log variable with some missing values are there. So so what you do we have changed this to log 1. Okay. So that can able to replace your value. All right. There are certain operators and expressions, operators which we add in addition, options we give in addition to our main command. Like arithmetic operation we add like subtract, multiply or divide or like raise to the power. So that symbol will apply. Adding will simply give this kind of command, plus. Okay, or subtract, minus etc. So some logical command like if it is not, this is not equal to this, then this command has to be given. Okay, or is for this, and is for this, these and this and signs could be given. Similarly, some relational function are also given. If you want to define within a range for your or variable, then some command less than or equal to can also be given. Then next one is called recode. Recode variables are often not coded the way we want. Like in NFHS, you will get some files called recode. How individual recode. They have recoded the file and made handy for your use. Variables are often not coded the way we want, often with too many categories or with values out of order. With recode we can handle all records for a variable in a single step. The core of the recode command is a list of rules in each in parentheses that tell it how a variable is to be recoded. They can take the form like input value is equal to the output value, like if you recode this to that, like if we simply said recode this equal to that, that will be converting to a new variable. This is as simple as that. Simply recode one variable and it is a new name. If you wanted to give it, it will record it accordingly. So, then the input value can be a single number, the list of a list of numbers separated by spaces like 1, 2, 3. If want to recode, like their entries are 1, 2, 3. Okay. You wanted to make all those 1, 2, 3 entries to 1. Okay. And maybe 4, 5, 6 to 2, or maybe 7, 8, 9, 10 and onwards everything to be 4, like standard years of education. You want to keep it till 5 years as as primary, okay, upper primary from 6 to 10, suppose you wanted to keep it. So, then from 1 till 5 you wanted to keep a code as 1. So, that is going to recode it, okay, with 1. So, output value will always be a single number. So, recode, like here education I have mentioned as 1, you wanted to keep 1 as 1. So, it will continue with 1. Then rest 2 to 16, like years of education till 16 are there, all other you wanted to keep it as 2. Okay. Maybe 1 year you wanted to understand or give importance on the only persons is having education or not, then more than 1 years of experience or not. So, your 2 commands is specially going to give you whether the person is educated with more than 2 years of education or not. Okay. So, then generated a variable, okay, the original variable is this one, education. The new variable we have generated is we have given the name within bracket as edu, and data is very case sensitive. So, we have to specify with that particular name, and generate or generate any word you can write down with a comma. Comma should be given. Once you have given comma, Stata reads that you have started giving options. Okay. The above command will record the education which has 16 categories into 2 categories only. The generate option at the end is not required. If it is not there, then the original variable will be changed rather than creating a new variable. Like if you do not give generate command, then the same variable will be actually changed with its recoded value, but we are suggesting that you should give a new name. Okay, you might require the first variable as well. So, it is always suggested that you should give a generate command at the end. I strongly recommend that you should always use the generate option. This is what is written. Make a copy of the original variable before recording it. You can also specify value labels in each recording rule, like recode education 1 equal to 1 as not literate, like the value labels can also be mentioned at the time of recording. Not just the recording, we have recorded 2 to 16 as 2, but now we have defined they are called literate. Okay. Suppose we are saying they are the literate one. So, 2 will be labeled with a name called label, not label, labeled as literate. So, and at the end we have generated. So, label can also be defined, label of the value can also be defined. So, couple of more information are there, we are going to clarify now.Egen is very rarely used, but very important as well.Egen command like short for extended generate, this is in short we write as extended generate format, gives you access to another library of functions. Okay.Egen actually going to give you another library of functions.Egen command typically creates new variable based on summary measures such as sum, mean, minimum, maximum, etc. Suppose we are interested in knowing the average year of an operation of women entrepreneurs, or even average year of expenditure in healthcare, okay, for the person. So, healthcare expenditure, instead of calculating the average with the function like this number of year now by 12, okay, if we give it that way, that we can derive it, but here through eGen command we can quickly get the mean value. If year is our variable name, year is our variable name, then mean of that year is again written here as the variable name, mean is our command for the eGen command. So, eGen command we have added here as mean. So, that will be generating a new variable with the mean of that year. Similarly, mean expenditure, if you wanted to go get that, this is in fact one of the quickest way of getting the extended commands. eGen is wonderful for saving summary statistics as new variables. So, similarly, minimum, maximum eGen, for minimum value, maximum value can be defined. I think we have already done it earlier. So we have shown it how minimum, maximum can be defined in our normalization or standardization techniques. Okay. So, similarly, other indicators you can do it through your eGen command. So, rest of the details you can also follow our previous lectures on standardization, where we have already entered those commands. Last couple of information I am going to clarify on labels. So, good labels make your data much easier to understand and work with. Variable labels convey information about a variable and can be substitute for long variable names. Suppose you want to name our group variable as gender, we request stata as label that is the variable name as group to be renamed as gender. So, it will change to gender of that particular variable. So, we can see those things in our window and we can operate it. Since I have already spent huge time all those operations, probably I am not going to show it all those things. I am sure that you can do it. If you have still difficulties, I am sure you will come back to us and we will clarify. Label variable and label values, there are differences. Value labels are used with categorical variables to tell you what the categories mean. Like within gender we have values like 0, like 1, 2, 3, etc. So, 1 may stands for a label called gender, maybe male. 2 stands for female, or the reverse, or the maybe 1 for female, etc. But we have to define it from the beginning. From questionnaire or supporting documents, we have to find the meaning of these codes. Once you find the meanings, labeling the value will make your data more comprehensive. Value labels are a mapping from a set of integers to a set of text descriptions. So, the first step is to define the map. So, a map, like map is going to define you map name, let it be value. Okay. So, what the map name is, value 1 is like label 1, value 2 is label 2. In this label 2 you can write down as value 2 as female, value 1 as your male. So, map name, define map name, that map name is called map, maybe map or a variable name. You can write down code for gender code. Okay. If you are just defining this, the first command for us is to go by label define. This is the first command we generally give. Label define, what does this mean? Label define, we have defined in our case is sector 1 for rural, and that is map for us is our sector, okay, and 1 for rural and 2 for urban. Okay. Now, once the first command is done, then second command is label value. What the value we are giving it? Here is label values, variable name is sector, then map we have already defined the map, they are gender, sector 1 or sector in case of sector it is rural urban, or in case of gender it is male and female. Now, these two commands should go together, label values, sector and sector 2 times we have to write it down, then it actually sector in this case is our map. Okay. This is our map. So, in our map value, this is our actually rural and this is our urban. Okay. So, it will map the codes automatically. Why we are developing a map? Because like in your question there might be so many categorical variable with yes no. Okay. Once you have defined a map name as yes and no, in all variables wherever you wanted to label the values as map with yes no. So, simply on the place of that you enter that map value map name. Okay. So, it will convert the categorical values with the label with yes and no. Okay. So, these are all details, some interpretation we can do it for our health data, healthcare expenditure coverage that we have been following throughout. Rural and urban, how many percentage covered in rural, how many percentage covered in urban, whether they are under government insurance scheme or not, whether part of PSUs or not, etc. So, all those operations you can also work out through our NSS data and interpret accordingly for your use. This is we have kept it for just for your reference. I hope we have clarified all your details at a go. This lecture I'm 100% sure going to help you a lot. If you have difficulties, we are happy to clarify it. Thank you.